Hello, everybody. My name is Brandon. I'm a front-end engineer at Voltage, and today we're going to be talking about micropayments on Lightning. So thanks for joining. So let's dive right in. So I'm just going to give an overview of what we're going to cover. So we're going to start with the history of micropayments. We're going to go over kind of what the early people who were creating the web thought about this concept and some early attempts at it. Then we're going to look at current monetization methods for the web and kind of how the web actually ended up evolving. And then finally, we'll get to the fun stuff, which is Lightning payment methods, the pros and cons of different ones, the different projects and use cases that a lot of these methods use. And at the end, I'll go over questions you guys might have. So feel free to drop questions in the chat throughout, and I'll be checking both the chat and the questions tab. So yeah, so let's get started. Okay, so just to dive a little bit into the history of micropayments, the actual term micropayments was coined in 1960, way back in 1960, by Ted Nelson, before the web was actually even really a thing. And he was just kind of visualizing or imagining what a central like way for people to access information globally and digitally could look like. And part of the original thought that he had was that people should be able to pay small amounts for pieces of digital content. Ted Nelson, he's an interesting character. He also invented coined a lot of the other terms that are used on the web today, like hypertext and hyperlink. And so if we fast forward to 1992, Tim Berners-Lee, who's the guy who actually created the web, right, the World Wide Web as we know it today, he borrowed one of Ted Nelson's terms, hypertext and hyperlink, for the hypertext transfer protocol. So we know that as HTTP, right? Everybody kind of knows that today. And in 1992, he released the second version of HTTP, which included most of the error codes that we know today, most of the status codes, right? And so you see pictured here, this is like the original, I guess, second version of the HTTP spec that mostly stuck with us. And you can see one of those status codes is 402 payment required. So, we can kind of see like early on in the web, people were already thinking about how can we integrate payments natively on the web to provide a new set of user experiences that were previously impossible before this. So it's really interesting to me that this was kind of meant to be part and parcel of the original web. And it's something to kind of think about, as we are actually developing micropayments on Lightning. So the World Wide Web Consortium was created by Tim Berners-Lee, also known as W3C. Micropayments were a major goal right from the beginning. They actually went so far as to create the micropayment transfer protocol. So they literally like wrote up a protocol spec for this. But one of the key limitations, which I think is interesting as Bitcoiners, we see that it explicitly required a third-party broker to manage transactions for people. And with Bitcoin, we know that that piece of the puzzle has been solved, right? But it's just interesting, back then they didn't really have a way to solve that problem. So everything they thought about had to be through the lens of this, how is someone going to manage funds for users? And there's a quote from that protocol that I think kind of echoes a lot of the same problems that we have with micropayments today. So it says that there is a large interest in payment systems which support charging relatively small amounts for a unit of information. Here, the speed and cost of processing payments are critical factors in assessing a scheme's usability. Fast user response is essential if the user is to be encouraged to make a large number of purchases. So we kind of see already, we want to minimize decision fatigue, right? We want users to be able to respond quickly. And then something that's still a problem today is that credit card systems are pretty bloated and slow. And those are kind of the two factors, the infrastructure and the decision fatigue that users feel. And these are kind of the same problems we're having today. The World Wide Web Consortium continued to work on micropayments. Here's another interesting quote from them. They said, micropayments have to be suitable for the sale of non-tangible goods over the internet. With the rising importance of intangible, for example, information, goods in global economies and their instantaneous delivery at negligible cost, conventional payment methods tend to be more expensive than the actual product, right? So, you know, if you're going to pay for a picture with a credit card, well, the picture's worth less to you probably than the price that you actually have to pay just to make the transaction with a credit card, right? Like $1 to $2. So anyway, some early companies that looked into implementing micropayments, IBM, Compaq, those are some of the bigger players that were looking into it. DigiCash is another one of the smaller startups that was built around this idea. And there were a lot of startups actually being built around this idea at the time. But DigiCash is particularly interesting because of David Chaum. And I hope I'm pronouncing his name right. Tell me if I'm not in the chat. But David Chaum essentially founded a lot of concepts around digital cash that are still relevant to Bitcoin and Bitcoiners today. And he founded his company DigiCash based on this concepts that he came up with, particularly blind signatures and eCash. DigiCash was basically based around the idea that you could withdraw digital cash from a bank, have it signed, and then spend it with other people anonymously, right? So this was a private form of early payment that still kind of required an institution, a third party. But what's really interesting about this is actually still used in Fedimint, right? So these concepts are still used and relevant to Bitcoiners today. But unfortunately, DigiCash went bankrupt around the time of the .com bubble when it was bursting, essentially. A lot of these micropayment companies went under. And around that same time, Nick Szabo, who is another, very influential early Bitcoiner. A lot of people actually think he's Satoshi because he wrote BitGold about like 3 years, or he came up with the concept of BitGold 3 years before Bitcoin actually came out. But he wrote a very insightful and interesting article called Micropayments and Mental Transaction Costs, where he argued that while most people are focusing on like the technological aspect of micropayments and how that's a problem, he was arguing that that's not the real barrier. The real barrier is the mental transaction costs incurred in a user's mind every time they have to go out of their way to, make a payment for every small interaction they have on the web. And he argued that the decision fatigue, essentially, over time was going to be the main thing that stopped users from adopting the micropayment model instead of the infrastructure problems, because he believed that at some point that would be solved, and which we are kind of at that point today, right? We'll get into that later, but I just think this is really useful to keep in mind. So some takeaways here. Interest in micropayments existed before the web was even a thing, right? This was something that from the very beginning people wanted. The earliest internet pioneers wanted them, and can kind of be considered one of the big failed attempts of the early web. This is something that we all thought was going to happen, really, that didn't materialize. So, okay, enter Bitcoin, right? Bitcoin kind of changes a lot of the conversation and thought about what's possible on the web. And Satoshi himself was interested in micropayments. Quote here, he said, "We have to trust them," banks, the third parties infrastructure, right? "Them with our privacy, trust them not to let identity thieves drain our accounts. Their massive overhead costs make micropayments impossible." So Satoshi solved a lot of pieces of the puzzle, right? Solved the permissionless aspect of it with that the micropayment transfer protocol suffered from. Now we have an internet native currency, right? And for a while, it was kind of debated that micropayments could be a thing now with Bitcoin. This was really before I think a lot of thought was put into like block size limits and things like that. But it kind of revived a lot of this conversation. And so Mark Andreessen, he's, you know, a lot of people know who he is. He's the founder of, or he created Netlify, helped create Netlify, which was the, sorry, not Netlify, Netscape. Netscape, which was the first popularly used browser. And he early on, before Lightning, wrote an article on why Bitcoin matters. And one thing he said is, one reason media businesses such as newspapers struggle to charge for content is because they need to charge either all, pay the entire subscription fee for all the content, or nothing, which then results in those terrible banner ads everywhere on the web. All of a sudden with Bitcoin, there's an economically viable way to charge arbitrarily small amounts of money per article or per section or per hour, blah, 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 right? So, you know, this was kind of something that Satoshi knew wasn't really what Bitcoin was meant to solve, but it still revived a lot of interest in the concept. So one early example of a project that did this was called BitMonet. I think I'm pronouncing that right. But essentially, what I think is really interesting about this is the fact that you could pay for a pass to an article one time. You could essentially choose your subscription level, right? And I mean, this is something that I would love to have for when I want to read an article on, you know, just one article on New York Times or, you know, some random journal. I don't want to have to subscribe, but that's what they try to make you do, right? You get to read it for like 10 seconds and then you get a pop-up saying, hey, you subscribe to keep reading. It's like, no, I'm not going to do that. The article is not anywhere near that worth that much to me. So this was kind of an early concept that sketched out that idea. So now we're going to talk a little bit about content monetization today. So really there's three ways to do it, right? And mainly two. The first is to sell your product via subscriptions. You can sell your audience via advertising, really. So that's selling their data, selling their attention, essentially. Or you can ask your audience. Think donations. Patreon is a service, you know, that helps with this. Wikipedia asks for donations, right? And they're asking more and more lately. So with the subscription model, there's a lot of drawbacks, right? Really competitive markets with subscriptions leads to subscription fatigue. So an example of this is the streaming services like Netflix, HBO Max, Hulu, right? At one point, it was pretty much just Netflix, and it kind of dominated the market, and that's all you needed, right? Was Netflix. Over time, there became a lot more competition between these different streaming services, and what it forces people to do is there's only a select number of things that you'd be interested in watching at any given time, right? But what this forces is people now have to split their attention between a lot of different split what they're willing to pay over different movies and TV shows and stuff like that. So essentially, licensing for movies and TV shows are restricted, and now there's like a smaller subset of what's available on each of the individual subscription services, right? So this forces you as the user to choose which subscription services you're gonna have. You're probably gonna do something where you'll rotate over time after you've watched everything you wanted to watch on a particular one. So that's one drawback. Another drawback of subscriptions, subscribers tend to underestimate spending. This is something that's very common, right? You sign up for a subscription, maybe you do everything you want with that subscription, and then you move on to another one without canceling another one. I've been guilty of this. The free trial trap. This is another one where like you give them your credit card and they say, okay, you know, you can watch for free for 30 days or something, and at the end of that they'll charge you. But then what ends up happening is they kind of make it, you know, really difficult to cancel a lot of the time, or you just forget, and you end up paying that subscription charge anyway. So problems with ads. I would say there's a lot of problems with ads, right? In my view, it's a more dishonest business model, or it at least encourages people to be more dishonest. And this is just kind of a small subset of the things that I quickly, typed out that I thought were wrong with ads. But for one, it incentivizes invasions of privacy. It encourages clickbait over quality because it's essentially just trying to grab your attention so that you'll be more likely to click on an ad or pay for an ad, right? So instead of actually trying to make content that you would actually want to pay for, ad targeting and data selling, these two are interlinked. So, companies like Google or Facebook will try to gather as much information as they can about you, so that they can show you targeted ads that you're more likely to buy. Slows down websites. There's a lot more JavaScript that has to load now on the page, which makes for a worse UX, worse user experience. And another thing, ads are not static, right? They're getting worse. So if you've been on, I use YouTube a lot. If you've used YouTube over the past couple of years, you'll probably notice that there's more ads today than there were a few years ago. And so, companies like YouTube and Google know that as we become more dependent on these single services, we're not going to go somewhere else for our videos, most likely, or most people are not going to do that. So they know they can keep ramping up the number of ads. And then finally, ad blocker tug of war. What I mean by this is that people are getting more and more fed up with ads, and ad blocker use is increasing. But what this does is this makes people who are actually like creators trying to monetize content on YouTube or TikTok or something, this leads to, basically it makes it harder for them to get monetized, and it incentivizes the platforms to show more and more and more ads. And one last point I think this all kind of leads to is that when things are free on the internet, you are the product, right? Nothing is free. So it's good to keep that in mind. People were like, okay, Bitcoin provides a lot of solutions here, but in terms of micropayments, Bitcoin is slow and the fees are high. Luckily, we actually now have a solution for this, right? And that is the Lightning Network. So this is the fun stuff now. So the Lightning Network was introduced around 2015, 2016, or the paper was released around that time. And one interesting thing I think to highlight here is that if you notice, they talk about a decentralized system is proposed whereby transactions are sent over a network of micropayment channels, aka payment channels or transaction channels. So they actually, you can kind of tell they didn't know what term was going to catch on. And I think the term that kind of has caught on is payment channels. But throughout the article, they refer to this as micropayment channels, right? So from the very beginning, micropayments were kind of a central thought on what the Lightning Network should enable. Anyway, speaking to micropayments themselves, how micro can micropayments get on the Lightning Network? And they can get pretty small. I'm not going to consider there's as a lot of you probably know, micropayment or Lightning micropayments could go down as small as what are called millisatoshis. But those actually don't really, get basically rounded down if you ever need to go back to the Bitcoin blockchain and use the blockchain again. So I'm just going to talk in terms of satoshis. But one Bitcoin is 100 million satoshi. Right now, one satoshi rounded equals about 2 10,000ths of a penny, which is an incredibly small amount, right? So this allows for a lot of granularity, and I think more granularity than is really in use by any Lightning project I've seen out there right now. So really, we're limited right now by the technical capabilities of Lightning and our imaginations as to what we can build with this. So now I'm just gonna kind of go over and cover different payment methods on Lightning. These are just a few that I know about and am experienced with. So if you know more, feel free to drop those in the chat. Lightning Lightning development is happening every day, right? And it's very, very active. People are creating new things all the time. So this list is, I'm sure, going to be updated even just a year from now with many more. So yeah, I just want to point out this is not limited here. But Bolt 11 invoices, okay? This is the default protocol level way to pay on Lightning right now. So what this means from a user's perspective, it's pretty simple payment flow, but from a user's perspective, you will try to access a piece of content online, right? Let's say, you want a picture of a cat in a bathtub. And what you'll be met with is an invoice. You can scan that invoice or pay that invoice, however, with whatever method, and you'll be shown the content, right? So it's pretty straightforward. One example I'll use, and this is one of many examples, since this is kind of the base layer upon which all other Lightning payment methods, or almost all other Lightning payment methods, are built on right now. You'll see this on most sites. But one example I like is micropay.ai. So this is an example where you can have Dolly, which is like the AI image generator. You can have it generate images based on a prompt you provide for, in this case, 1,000 Satoshis. So, a few cents, 20 cents or something. So here you can see that's what I did. I scanned the QR code, gave it a prompt. I asked for a Bitcoin Lightning payment, and it gave me pictures of Bitcoin being struck by lightning, which I guess is close enough. But this is just like an example of what it would look like from a user's perspective. Okay, so some pros and cons of the Bolt 11 invoice method of paying for things. So this is really the least abstractions from a technological level, right? This is Lightning. This is how Lightning payments are made under the hood for almost everything today. So it's available by default because of that in pretty much every Lightning implementation, and payments occur directly node to node. So there's no outside third party, any of that going on at a fundamental level if you have a node and you're paying to someone else's node. So some cons of this: invoices can kind of be an awkward user experience, right? It's kind of weird that you have to, as a user, send an invoice to someone else and then say, hey, please pay this, instead of them just being able to pay you directly, like you can in Bitcoin, for example. So it's a little bit of awkward UX in that sense. And then another aspect to keep in mind is that they're non-reusable. So once a Bolt 11 invoice is paid, that's it. It's paid. You have to generate a new one for a new separate payment. And so this kind of limits the scope of a lot of things you can do that some of the other payment methods solve. Okay, so Keysend would be the next kind of protocol level way to pay. Keysend, the cool thing about it is that you can send directly to someone's public key, right? You don't actually need invoices. You're not limited by that the same way you are with Bolt 11 invoices. So the problem here with Keysend is that the way it works, there's no actual proof of payment. So with Bolt 11 invoices, you can prove that the person paid, and that's kind of a necessary thing for most payment systems, right? But with Keysend, you don't have proof of payment. So really, what it's evolved to, kind of the niche that it's evolved to fill, is more donation models and value for value, which we'll talk about which we'll talk about here. So value for value is essentially this idea that you provide access to content for free as the content creator, right? And you ask people to pay you based on how much value they feel they got from what you're offering, right? And so this is kind of in the hopes that this is related to the idea that information wants to be free, right? So it's kind of, if you think about it, it's kind of silly to charge for information, since that's something that can be replicated endlessly, especially on the internet. So the proponents of value for value are kind of pushing this that thought to the max, where it's like everything is free by default. Please give back what you feel you've gotten from it. So some examples of this are I believe Breeze, the Breeze wallet, does this, where you can listen to podcasts and you can stream Satoshis as you're listening, like by second or by the minute or whatever. And then another aspect, or another use case for this, is what's called boosting, which is essentially, I believe that's just a term for sending key payments basically now, or Keysend payments. But here you can see on podcast index, you can, boost at any given moment while you're listening to a podcast. You can send a certain amount of Satoshis just directly at any time to the content creator. And a boostagram would be if you do a boost, but you send a message along with it, because Keysend has that capability. So these are kind of some of the use cases for Keysend. So some pros with Keysend: you pay directly to a pub key instead of an invoice. So, maybe smoother UX. It's available by default on most Lightning implementations, but it needs manual activation. So for those of you, if you're running a Voltage node, you can enable this if you're logged into Voltage by going to the Settings tab, clicking Basic Node Settings, and then toggling Keysend on. Some cons to this, like we talked about, there's no proof of payment with Keysend. So you kind of just have to use the donation model for this, or the value for value model. Yeah, it's not really suitable for things where you require payments. Okay, so LNURL, this is a fun one because there's so much that goes into it, and I'm not going to cover all of it. I'm just going to cover LNURL Pay specifically, since we're talking about micropayments, right? But this is something that, if you don't know about it, it's really worth checking out. LNURL is essentially a set of standards that gives guidelines for services, which basically means something that's not a Lightning node, to communicate with Lightning nodes. And a lot of Lightning UX today that you'll see in the wild is built on LNURL. So, especially LNURL Pay. So the way this might look from a user's perspective is you can do, let's say, the same thing as the value for value model, except now the creator has proofs of payment, right? So if you're a user, you could be paying to a static QR code. That QR code is reusable. It doesn't need to be regenerated every time, because under the hood, what's happening is the LNURL that the person is scanning is communicating with us, is using a service basically to generate invoices on your node's behalf. So that's kind of how it's working under the hood, and the service kind of manages that interaction for you. But at the end of the day, it's really Bolt 11 invoices that are being paid, right? So and then on the right here, you can see, like, you can still have you can still require payment for access to content, but now you can have static QR codes to do it, right? So a fun example is CoinTrain. So I'm gonna break out of the presentation for a minute to demo this. Yeah, so this is a live demo, so I hope this works. But you can see he's got his QR code just sitting there, right? Whoever set this up, and this is an LNURL. So if I scan it, I'm going to pay it now, and hopefully, if this works, it'll the train will activate, right, and it'll start going around the track. And okay, so we can see, there it goes. Thank you. Your invoice comment goes here. I should have said something. But yeah, so now the train's going around the track, and all I did was scan this QR code that's in the video, right? So it's almost like I'm making an offline payment from his perspective, even though the services that are using it are online. But the content creator doesn't need to have like a way to be online to use this. So anyway, that's a really fun application of LNURL. There's a ton that goes into that. But anyway, let's continue with the presentation here. Okay, so yeah, so CoinTrain. Another example is Lightning addresses. So Lightning addresses are essentially ways to map. If you own a domain, essentially you can map your Lightning address to, or you can map an LNURL to like an email address. So what it looks like essentially is an email address from a user's perspective. But this allows people to make payments to each other, without having to copy and paste a long, ugly string of text. And you can just do it, almost like as if you're sending an email to someone. You can send money to them, right? So really cool use case there. That is in wide use in a lot of places. And then I just put this and so much more here because LNURL is so much more than just LNURL pay, which is what is demoed here. There's a lot of stuff going on for LNURL that just simplifies Lightning UX, such as like authentication. You can essentially log into websites using your Lightning node. You can withdraw money from like ATMs using this. So yeah, a lot of applications. Look into it if you have time. So some pros of LNURL pay specifically, you have static and reusable pay links, right? So now you can just post these, I could tape them on my wall if I'm a content creator, like in a video. I can have things. You can basically go offline yourself and still get paid for things, which is really cool. Some cons: LNURL operates out of band. So like we said, you need a service to communicate to your node on your behalf. You can self-host this service, right? So you don't actually, you don't necessarily need to trust anybody other than yourself, but a lot of the times people will use outside services. They won't set up the hosting or whatever themselves, and they'll be reliant on third parties here. Okay, so another abstraction on top of Lightning nodes is webLN. This is a really interesting. It's basically a JavaScript library, but it's also like a spec, specification for browsers to. We can call them clients, but this is essentially for browsers to interact with Lightning nodes. So what this looks like from the user's perspective is, I want to make a payment. I want to see this cat jumping in snow. So I click to try to access it, and then a browser window pops up instead of a QR code. So I don't have to pull up my phone to scan anymore. I can just click pay in the pop-up, right? And so my browser extension is managing the interaction between the website, as long as the website has integrated this webLN library. And then behind the scenes, that browser extension is interacting with my Lightning node on my behalf to conduct payments or do whatever it needs to do. So this makes using Lightning on browsers a lot easier. So some examples, there's a ton of projects that use this, but some examples are Stacker News. So if you've ever gone to Stacker News is basically like a Reddit with Lightning essentially enabled, to where you can tip people for posts that they make. But if you want to fill up your Stacker News wallet, it can show you a QR code, and then you can, if you click on the QR code, this pop-up will come up and you can just click pay. BTC Map is another example. It's the example pictured here. BTC Map is basically a project that tries to map out all the places that accept Bitcoin. And if you have a particular location that you want to support, you can click on that QR code and just click pay now, instead of pulling out your phone. So there's a lot of other things webLN can do other than just micropayments. But yeah, this is one really interesting use case. So pros and cons: better UX if you're interacting in a browser. It's a simple implementation. There's not too much to it, and there's no third parties required here. This is really just a JavaScript library. You do have to give permission to, like, one thing to note is you do have to give permission to the website that is like webLN enabled to control your browser client. But there's a lot of controls in place so that, like, for example, your browser client's always going to show you if you try to make a payment, or if the website tries to make a payment, it's going to pop up and say, hey, do you approve this payment? So, hopefully nothing's going to happen behind your back or without your approval, of course, but assuming it's properly secured. But cons, browser clients is required. So if your website just builds webLN and doesn't build any backup, what happens if I don't have a client, a webLN client or a browser extension? Then I won't be able to make a payment on your website. So you need to code with fallback options in mind, like LNURL or invoices. And this is typically the case, right? We normally see an invoice pops up, and optionally you can click the invoice to pay with webLN. Another downside is there's few clients in use. In fact, I only know of one, which is Albi, the Albi browser extension. If you know of more, drop them in the chat. There used to be one called Joule, but I think that is actually the project that Albi is now based on, and Joule is kind of deprecated. So, but anyway, so it would be nice to see more optionality in that space. So finally, LSATs. This one is not too well known about. Oh, Zebedee. Yeah, Zebedee has a browser extension. Okay, yeah, that's right. I actually have used Zebedee's browser extension before, but it's been a while. So thanks, Brad, for the reminder. But LSATs. So this stands for Lightning Service Authentication Token. This is a protocol for authentication and paid APIs. So really all it is at the end of the day is it's a macaroon paired with an invoice, right? And once that invoice is paid, the LSAT, it basically replaces the invoice with the pre-image of the payment. So now you have a macaroon that is tied to a piece of content, right? Those are the permissions essentially given to it. And once you attenuate that LSAT with the pre-image, now it's essentially proof that you have paid for this specific piece of content. So this is a really powerful idea. It's kind of confusing to think about and to implement, but the implications of it are really interesting, because what it means is you can actually pay for like individual pieces of content on a website, and then leave that website and then return to it, and it'll, you can basically show what you've already paid for on subsequent visits to the website. So this just kind of opens up a lot of floodgates, in my view, for what's possible. But unfortunately, there hasn't been like too much development on this. So one example, oh, okay, I forgot about this slide. Yeah, if you already have a ticket, then like if you already have the LSAT, saved to your browser or whatever, then the content will just automatically be shown. That's like the ideal user interface. One example of this is Nakafoto. So if you go to nakafoto.vercel.app, you can actually play around with this LSAT idea, and you can pay for an image. The image will be blurred initially, but once you pay for it, you'll be shown the image. But if you exit out of the browser tab and come back, assuming you haven't cleared your browser storage, you will be able to see the image now. And so that's kind of one example. You can see all the images that you've paid for, essentially, right? So some pros and cons here. Extremely flexible. I mean, you can essentially, with a macaroon, you can essentially like put in any rules that you want for content on your website, right? You can do things like metered subscriptions and have the macaroon, have the LSAT expire after a certain period of time. You can create access to different, I don't know, it's like the possibilities are very widespread here. they're reusable, right? So when you come back to the website, assuming you have it, it'll just detect that you have this permissions to access this content, and it'll just show the content. And another interesting thing about this is it actually makes use of the 402 error code. So when you're initially shown the invoice for the first time you're paying, if you were to go into like your browser or whatever, you could see one of the headers for it is 402 payment required. So this finally makes use of the 402 error code that was initially put in there for basically this purpose. Some cons of LSATs. It's hard for users to know when their permissions to pieces of content have been revoked, right? So if you want to update, if you're like a content provider and you want to update people's permissions, it's hard to do that because of the decentralized nature of the LSATs, right? You don't have to know anything about the user for this scheme to work. So yeah, it's a little bit difficult to control versioning and permissioning with LSATs. Another con is mainly just currently it's pretty underdeveloped, which is in my view, it's kind of sad. Like a lot of the libraries for working with it, like if you can Google Boltwall or Lsat.js, these are some of the libraries. They haven't really been worked on in a couple of years. So which is like, I think 3 years ago is when Lightning Labs introduced this protocol. So it's underutilized today, and I think there's a lot of potential here that would be really cool to see people build on. So now I'm just gonna kind of freewheel it and just go through some ideas that for micropayments that I think would be really cool, that we can hopefully spark some people's imaginations for what's possible. So one idea is scroll to pay. This is an interesting website that demos a lot of webLN capabilities, but one of them is scroll to pay, where instead of a paywall saying, "Hey, subscribe for this content," you can just scroll and pay as you go. And the interesting thing about this is that if you want to smooth out this user experience and kind of minimize the mental transaction costs, you can set a budget. So you can actually just scroll as you go, and it'll just load the content, and you'll just kind of pay invoices behind the scenes and read the content without an annoying paywall popping up until you've met your budget, right? And I think that's a really cool compromise here. Another idea is tips on existing sites. So this is kind of a way to take advantage of the economies of scale that websites like YouTube have. So for example, here, Albi, with the Albi browser extension, they put one of their Lightning addresses in their description of the video, and the browser extension will detect that the Lightning address is on the page. So it'll allow you to be able to tip them, even though YouTube has done nothing to enable Lightning, right, on their website. It's just the fact that the browser extension can detect that the Lightning address is on the page. So this is really exciting to me because you can imagine things like Stack Overflow, right? You can tip people for good answers, or Twitter. Twitter already kind of has a tool built just for Twitter called tipin.me, but that uses like a managed Lightning wallet, whereas this example here, these are just your funds, right? This is your own node. So that's really exciting. Another idea, Thunder Games has games where you can play to earn, right? And I've actually earned a few Satoshis on this Bitcoin bounce game. But this can just be another idea to help spark interest and gamify interactions with Bitcoin. So this one is a really interesting one. This was actually built by one of our own here at Voltage, Lightning Koala. So shout out to him. This is Satoshi's Place. This is basically like an artboard, a giant artboard that you can pay per pixel to draw, to put whatever you want on the artboard. So here you can see I'm drawing like just a boring little smiley face, and then an invoice pops up and I pay to have that on the artboard. So yeah, this is a really cool, I think, kind of innovative use of micropayments. So anyway, good job, Lightning Koala. And then one more idea. This allows for flexible subscriptions. So this is LNVPN. This is a website where you can essentially pay for however long you want access to a VPN, down to the hour, right? And you can see at the hour level, you're doing a micropayment, right? You're paying 10 cents for 1 hour of access to a VPN, if that's all you need. So this is just I really love the flexible subscription idea, because I think so many barriers to payments on the modern web come from this, the limitations on subscriptions right now. Okay, and then I wanted to put in a little note on Nostr here, and the potential for micropayments on that. So if you don't know, Nostr is a stupid, simple, censorship-resistant open social network protocol. And this was created as essentially a Twitter alternative, but a censorship-resistant Twitter alternative, and one that's not a company, one that's a protocol, right? So anybody can build on it. And because it's so simple, a lot has been done on it in a relatively short amount of time, which is really exciting. So this has been moving very fast. And because it was built by a Bitcoiner, and it's kind of was initially released into the Bitcoin community, it's mostly Bitcoiners right now who are on it and using it and building with it, right? So micropayments are kind of a first-class concept on here, on a lot of these clients. So for example, Damus is the iOS Nostr client. You can download it on the App Store. It uses LNURL to allow you to tip profiles. Snort.social is another client. It allows you to tip notes. So notes are basically like tweets, right? Like individual posts via regular invoices or webLN. Another really interesting use case is paid relays. So you can, if you want a clean global feed on Nostr, then you can pay to join these paid relays where bots are basically not allowed to spam, or because of the payments, right? It's prohibitive. So there's no incentive that kind of reduces the ability for bots to get steam on paid relays. So another note on Nostr, it's growing fast. Keep up to date with it. There's a lot of cool stuff happening. And so finally, we're pretty much getting to the end here. This is just a list of links that I found useful in learning about a lot of this stuff. If you want to explore and learn about more projects using micropayments, visit any of these links. Bolt.fun is really interesting. They do hackathons every once in a while, and you can kind of showcase your projects there. But yeah, and then if you want to participate by learning and building, then these are different websites that I used to kind of learn about the topics and play around with some of them. So, and this kind of covers the subjects that we did today. And so one thing I want to note: if you run a voltage node, it comes with an LNBits dashboard, and LNBits has a lot of LNURL plugins that you can play around with. So definitely check that out if you run a voltage node. And so that's really it. That pretty much concludes the presentation. And I just want to say, like, micropayments are here, right? They've arrived. We're living in it. So this is it's a really exciting time to be working on this. It's a really exciting time to just be on the internet, right? One of the original visions for micropayment, or for what the internet should have been, is now being realized, right? So thank you everybody for joining. Really appreciate it. And yeah, let's keep building. Let's explore the possibilities, huh? So thanks everybody. I'm gonna conclude the event. So thanks everybody for joining.